So now we are going to move on to our first session of this conference, and this is all about operating sustainably. So we have, of course, the challenge of meeting our net zero obligations and at the same time operating within a climate-changed world. We also are going to, in this session, reflect on the progress that we've made since that key declaration on climate was signed by global chiefs at last year's conference. And the architect and driving force behind the collaboration last year was Group Captain Kevin Billings, who in a moment will tell us a little bit more about the progress being made. But please do welcome all of our panelists for this next session onto the stage.
Good morning. It is a pleasure to be here today. And as Air Vice-Marshal Edwards said, last year, 34 of you, or your predecessors, signed a historic declaration recognizing climate change as a threat multiplier and created the Global Air Force's Climate Change Collaboration. It has been the privilege of a lifetime to work with so many dedicated and talented and forward-thinking airmen and women from around the world. So I want to thank you for the opportunity to lead the collaboration. The collaboration has, over the last year and a half, we've stood up 6 working groups, and we've had over 10 collaboration events. We've had the opportunity to, in the last 3 months, we've had 3 inaugural working group sessions, one on fuels led by the RAF, one on training led by the German Air Force, and one on disaster relief led by Kokujetai. In the next 3 months or the rest of the year, we're expecting to have at least 2 more collaboration events across the world. And next year, our goals and ambitions are equally aggressive. We are hoping to plan to have another set of working groups in terms of across the board. We are going to stand up a space working group. We are going to have another Deputy Air Chiefs meeting, and we are also going to have a working group summit where we will bring together all of the working groups in person in one place. And we will also be planning a Global Air Force's climate change tabletop exercise for 2025. One of the things, and I think this is probably the biggest tribute that our air forces have been given in as this has been going on, is that the first Sea Lord has come to the air forces requesting support and advice on how to set up a global Navy's climate change collaboration. Let that sink in for a bit. So as we move forward, and as we talked about last year, the fundamental and overarching principle, and the reason that we are doing this, is to allow our air forces to better be able to fly, fight, and most importantly, win in a climate-constrained environment. This is all about winning the fight, whether it be on NATO's eastern flank, in the Pacific, or in space. So as we move forward today, and as the panelists talk, I want you to engage your imaginations in how we look at how we fight, and not use climate change only as a burden to think of something we have to do, but let's turn the prism on that and think about it as an asymmetrical advantage. Think about the way we fight, the way we can integrate small, attritable, cheaper, and autonomous weapons and systems into the fight that will allow us to engage smaller, cleaner technologies such as solar and wind and small nuclear and advanced battery technology at the front. So we are not faced with having long logistics tails during the fight. In Iraq and Afghanistan, 60% of the casualties were protecting convoys. And if we don't have to do that, and we turn the prism on how we think about how we fight and the things that we do, we will be able to become more efficient, more effective, and more lethal, while at the same time taking care of our carbon footprint. It can be both, and if we use our imaginations and move forward with that, we can do that. So, as I used to tell my staff in the Pentagon, it's great to have a great imagination and think big thoughts, but imagination without execution is hallucination. So I want you to be able to take this and execute with it. And what I'm going to leave you today with the same counsel I left you with last year at the end of the conference. And it has borne out over and over again throughout the collaboration that no one individual, no one cohort, or no single nation is as smart or effective as we all are together. So again, thank you so much for the opportunity to lead the collaboration, and I'm going to turn it over to our panelists now. So thank you.
Thank you very much, Kevin.
Cool, thank you, Kevin. So the climate change is already amplifying the traditional causes of conflict. And when I say amplifying, I mean the direct physical impacts of climate change. We already know it's impacting on human security, water security, nature security, energy security, and a whole host more. So when we talk about climate change, and reinforcing actually Kevin's points, it will change where we operate. It will change how we operate. It will change what we operate, what we need to operate, and it will change who we need to operate with. And the elements of all of this are linked to almost the profound value of what defence is, which is our ability to be resilient and adapt to any threat. And I would basically offer that climate change is probably a non-state threat. But as you can see here, I'm talking about physical risks. As we go through the transition to a low-carbon economy, there are going to be other indirect risks that come from that transition as well to defence that we need to be resilient and adapted to. Principal one of those is a transition to a low-carbon economy. That will give us vulnerabilities as the entire world moves to a low-carbon, moving away from fossil fuels, but it will also give us opportunities, exactly how Kevin was saying in terms of that, what's that asymmetric opportunity that we can actually get. And I think last year, the Chief of the Air Staff talked about how militaries were reflections of their society. Again, as things change, regulation comes in, we will also be asked to change by our general public, so we need to change to ensure our license to operate. That doesn't mean that we should be green for green's sake, it just means that we actually need to understand what all those interfaces are. We need to understand how we are resilient and how we should adapt to the threat that is climate change. So in terms of the UK MOD, I've got three long-term ambitions, and they are long-term, they're for 2050. Defence has to adapt and be able to fight and win in ever more physical and hostile environments. Defence should reduce its emissions and fully contribute to the UK's net zero legal commitment, and I'll talk a little bit more about that later, and I'm sure Paul will as well. And the third one is that Defence acts and is recognised as a global leader in response to the emerging threats of climate change. Now, I mentioned 2050 as a long-term away. All the service chiefs and my permanent secretary have given me near-term objectives and priorities, and that helps drive some of the change across Defence. Across Defence, we have active directors, 2 stars in each one of the TLBs and our enabling organisations who look in terms of their own organisation in terms of driving that change. And indeed, Paul is one of those. But in terms of those priorities, first priority is to essentially integrate climate risk and ownership into Defence. That's essentially mainstreaming those risk considerations into how Defence operates and functions as an organisation. The next one is essentially looking at the security implications of climate change. And that's thinking through those security implications that we were talking about before, thinking through how some of that could affect force development scenarios, thinking about how some of that could also impact our capability management decisions as well, to be fair. The 3 other ones that follow it, building functional enablers and tool sets. At the moment, I think it's fair to say that we all speak a slightly different language. We need to come together and speak the same language, have the same outcomes. There's an awful lot of good work going on across Defence and indeed across all our allies and partners. This is a team sport. We need to come together, have shared standards, have a shared understanding of what the outcomes are that we need to be delivering. The fourth one is when we start to change those standards, we need to have training courses in place. And Last week, Defence went live with its climate change awareness course, which is available for all staff, no matter whether they're civil servants or military personnel. But that's just a base level of literacy. As we start to change some of the policies, change some of the processes, we need to make sure that senior decision makers actually understand the climate considerations when they make a decision. So again, it's a resilient and future-proof decision. And the final one is that Defence has to identify its own decarbonisation trajectory. The UK Net Zero strategy was mentioned before, was signed some time ago now, but the actual strategy documents and the underpinning sector strategy documents are all now starting to be developed. The policies that are required to deliver the UK's carbon budget are starting to be developed and invested in. And Defence at the moment does not have an exemption to those policies. We've done some work, and essentially each one of the sector trajectories that are in the UK Net Zero strategy are applicable to Defence. The policies are applicable to Defence. So we've rebaselined our emissions and we've looked at the effect of those policies. You can see those policies on the left-hand side in terms of the wider UK economy trajectories that are suggested. And Defence has emissions in every one of those sectors. Surface transport, buildings, we have 40,000 service families accommodation. We have another 40,000 buildings around that. We have our own industrial base, and many of you also have your own industrial bases. We consume an awful lot of electricity. We've got our own land. We've got 1% of the UK landmass under direct ownership. We also have aviation emissions and a whole host more. So we know we have to change. But we also know that as those sector trajectories are delivered by the wider private sector, that they will have impacts on us. So we're doing an awful lot of work. Kevin, through the GAC, has started to drive some of that internationally. But working with RAND, we've understood some of the actual climate dilemmas that are actually out there. And that's actually an open source document. You can all actually get that from the web. We've also built our own climate risk assessment methodology, again, to start to understand the changes that are required across our estate, across our capability management processes, across our people function, across our commercial function, across our finance function. So we're starting to get the information feeds in to bake in climate considerations. We've also got a capability review underway that's looking at the legacy risks that we're currently holding due to the changing climate, but it's also looking at how we actually need to change our future requirement setting going forward as well to make sure that we're limiting the risks we're holding. And again, potentially informing some of our long-term capability decisions and potential contract breakpoints. But above all, the information that we all need is actually out there. We have the Met Office, many of you have other data sources, but fundamentally, this is actually a team sport in quite a lot of cases. We should be sharing quite a lot of this information, we should be sharing our approaches, and we should be sharing our outcomes. If we can do that, we can drive some change, and above all, we can actually ensure that we remain interoperable as we go through the transition to that low-carbon economy. I'll probably stop there.
Thank you very much. Now let's hand over to Air Vice-Marshal Paul Lloyd to give the Royal Air Force perspective.
Good morning, everybody. So I'm Paul Lloyd. I've got a number of hats. I'm Director of Support within the Air Force, so I look after all equipment support, logistics, and also infrastructure. I also wear a hat in terms of providing the lead for climate change across the Air Force. But what I'm standing here for today is my role supporting James as a sectorial lead for Defence Aviation. And that's the bit I'm going to cover today. And what I'm particularly going to cover today is what is the UK, what has it done since we last met a year ago, and what is it doing about this challenge. And the big news is that this week we are releasing our Defence Aviation Net Zero strategy, which details how we are going to get after, from a UK defence aviation perspective, the challenge we face. And I'll just talk through some of that now and give you some headlines. And again, they'll be available later. So I think when I do this, the conversation first is always why are we after climate change? And James has laid out some of the challenges that it faces, both from an operational point of view, but also from a domestic and equipment support side of the business. We have absolutely got to be able to operate in a climate changed world. We've already seen that and are seeing that. Our equipment was set up for a world that is changing, and we've got to be able to deal with that. And that's something we need to make sure we get after. But more importantly, whatever we do on net zero or climate change has got to not in any way degrade our operational effectiveness. We can't afford that to happen. We've got to maintain our operational edge, and that is a common across all the air forces here represented. So whatever net zero activities we do need to make sure that our operational resilience is improved. And the good news is that By going after the new technologies, we're actually finding that in many cases that helps to both improve our resilience, our effectiveness, reduce some risks for us that have a benefit that is climate change or net zero positive. The obvious ones are around our ability to use solar power and basically for a deployed operating base to be able to look after itself energy-wise. Clearly, that means we don't then have to rely on host nation support for energy. You've heard from Kevin already, so many lives were lost moving our fuel around to support our operations. We can provide that elements of that fuel or produce it locally, then we reduce that reliance on that. We reduce our supply chains. If you can 3D print parts locally, then of course you can then have to have those supply chains that go with it. So there's a number of factors there that actually we focus on resilience and operational effectiveness that have a benefit to climate change. And I know in some nations that's the approach that you're taking. Nevertheless, there is an element around defence and UK defence and all defence air forces doing the right thing. We are seeing now that the way we are perceived, the way we operate is important, and therefore our licence to operate is dependent upon that. We probably less in the air sector, but certainly with my colleague Admiral Paul Beattie, who looks after the maritime, is seeing already that some of their shipping has been denied access to ports if it's not of a certain standard. We're not there yet in aviation, but you can see it starting to come. So if we don't move with the times, if we don't show that we are on this trajectory, then there could be a limit for us in operations in the future. It's also a very competitive world out there, and we're all struggling, aren't we, to attract the best people, and therefore we need to make sure that we offer the best offer we can to the people out there. And climate change, net zero, is a factor for many of our younger people today. So we need to make sure that we access those talented workpool and we offer them a career that they want. But also, we've got to play our part, as James has said, from our defence aviation perspective, to deal with the climate change commitments that have been made, are being made, and will be made. So we've got to get after that. So that is our main thing. So the question is, how are we getting after that? What are our broad areas? And they fall into 4+1, 4 areas of activity, and then an area at the bottom, which is kind of the catch-all, which I'll cover. So these are the broad strategies or pathways that we're going to take to get after getting defence aviation to net zero. The first one is around rethinking capability provision. Now, what we mean by that is how can we do this differently? The obvious way is greater use of synthetics. If you're in the airlines, if you're in the civil sector, then you can look at how you can reduce demand in order to address that. As we said before, from an operational perspective, we can't always reduce our demand, so we need to be able to be operational effective. Nevertheless, we do need to find ways of undertaking more work synthetically, and the technology is certainly coming along now, as we see with our F-35 forces. That's already there. We're working on our Eurofighter Typhoons and other forces as well now to be able to download or move capability onto that synthetics. And that's certainly something moving forward, which, again, has a benefit of reducing emissions. We've got to be more efficient, and that just helps in a number of areas, from including, financial side of the business. How can we make our flight planning, our air traffic management, the way we plan and fly our sorties, as efficient as possible? That has a benefit of lengthening sortie lengths if we can as well, but also reducing our emissions. So we need to get after that and find ways of making both the way we plan and execute, but also the technologies we implement on our aircraft going forwards and our platforms going forwards, are they going after efficiency? And there's a huge area of that going forwards. Whenever you come to the defence aviation or any form of aviation, be it civil sector or defence, in the sort of 2050 timescale, and that's where we're setting ourselves, then sustainable aviation fuel is by far one of the most significant contributors. And you see on the right-hand side, we're saying that's in the order of just under 35%. So we estimate that the contribution that makes to get us, we think we need to make, and realistically, is about 35%, 34% of the contribution to reducing the emissions. There's a number of, we use a catch-all term for sustainable aviation fuel. There are 7 different pathways of producing the fuel, from biofuels to using old oil, to ultimate, which you want to get to, which is called power to liquid, which basically you create green hydrogen. From green hydrogen you mix with carbon that you've captured, and from that chemistry you produce fuel. And that has been done, and we've already trialled that through the RCO, and we already work investing in plants to get that moving forward. But the problem is the scale is not there yet. Last year we flew a Voyager on 100% SAF. That was to show that, first of all, there's a clearance activity and we are ready for the new fuels as they come, but also to kickstart that industry, because it is challenging out there to get the plants built. And whilst the Defence DFT has said we want, our Transport Department has said we want, I think, 3 plants by 2025 in production, we need the finance to do that. And I think Defence and the MOD has a wider role in helping to kickstart that, because we need that fuel. At the moment, it's 4 to 5 times the price. And again, the Treasury won't be terribly happy if we go that route. So we need to find ways to reduce those down and increase our use of that fuel, which across the life cycle is significantly better for net zero. Ultimately, we all want zero emissions. That is the kind of the goal. In the 2050 timescale, and when one looks at the capability we've got out there, it only, as you can see, plays a very small part. About 1% of our emissions will be dealt with by zero emission aircraft. That doesn't say, though, that in the time frame we're moving to, the technology does not kickstart. We're already seeing through some of the small rotorcraft that are being produced, the sort of air taxis, that is a massive growth area. And I think in the rotorcraft area particularly, that's an area we can see a growth of net zero or zero emission aircraft. Same for some of our training fleet. We've got a program there to look to replace some of our Choosers Grobs with that capability. But when it comes up to where the motion emissions are coming from, the big aircraft, then we are probably a generation or two away from those zero emission aircraft. Are they hydrogen? Well, they can't really be battery, because those batteries are far too big and cumbersome. So how do we get the hydrogen? What's the technology? So whilst as an emission reduction over the period, it's probably likely to be small, we certainly need to get involved in those technologies and make sure that we are leading that discussion from not just a civil sector, but from a military and defence sector point of view. But whatever we do, and this is common across all the strategies, is recognise that aviation cannot be zero on its own. And we estimate that around 15% at the end of all this good work, based upon what we see coming at the moment, we like to be 15% short of the target, and therefore we need to find other ways of net zeroing that. As James said, we have a big estate, and that's probably the main way we'll do that. But that's something we need to work on. How do we carbon capture? How do we deal with that issue going forwards? So as I said, the strategy is out. It comes out this week. So as we move forward from this conference and the excellent work that Kevin particularly kicked off, the Global Air Chiefs Climate Change Collaboration, which has been a bedrock for the international side of the business, and through the Defence Suppliers Forum with industry and academia and partners to move this forward, we've now got to produce a plan. What is our plan to actually get after this? There are a huge number of activities going on. We need to brigade them together, work out their contribution, and start monitoring them and helping them to drive them forwards. We're going to work across our partners and particularly other departments. We have the Jet Zero Council from the Departments of Transport that we are heavily linked into. We are really a fast follower in defence, in most cases, apart from Combat Air, which again is not many airlines have Combat Air. So that's likely to be our leading, but generally we tend to fast follow. So we need to work with cross departments with their mandates and help them, and DSTL and DNS and our other enabling organisations, in order to drive this work forwards. Absolutely need to continue to work with industry in that, and there's many faces here, recognised here, who've been on the journey with us for a number of years, but certainly in the last year, and I thank you for that, and that's been a huge part of it. And to show the commitment the industry is playing, on Friday, we're going to have a charter signed by the CEOs of some major companies to show their commitment with the minister, to show commitment to helping us within MOD to drive this agenda forwards. And that's a really fantastic step forward, which will carry on through DSI into next year and keep that work going. And absolutely, my point here is we've got to continue to engage with our allies. We're having some fantastic conversations, and I suspect the questions will go there as well later on. How do we engage together? How do we move this forwards? Certainly for the work that Kevin has kicked off, which is absolutely fantastic, and I'm keen to carry that forward. So thank you very much.
Thank you very much, Paul. Thank you. So let's get the international perspective now, starting off with the United States and Roberto Guerrero, who's Deputy Assistant Secretary for Operational Energy. So do welcome Roberto to the podium. Thank you.
Yeah, there we go. Had a little malfunction there. Yeah, so Bert Guerrero, I work for the Assistant Secretary of the Air Force for Installations, Environment, and Energy. So I'm the operational energy person. Background is I was a aeronautical engineering student in college. Saw Top Gun 1 back in the mid-'80s, and then next thing you know, I'm in Pensacola in flight school. And I've spent my time in career 20 plus years flying various different Navy and then Air Force aircraft, and then transitioned to the senior executive service and to this job about 8 years ago. So I'll talk to you a little bit about what the Air Force's strategy is with respect to sustainable aviation. For us, it's about mission capability, and I'll tell you how we got there. So the bottom line for us, as Kevin alluded to earlier, that in Iraq and Afghanistan, a high number of the casualties were not, soldiers and Marines and airmen in conflict. A high number of the casualties were actually delivering fuel and water supplies to outposts. And so from our perspective, we think about aviation fuel and what risk we're going to see in aviation fuel logistics, supply chain logistics in areas like Europe and the Pacific, where you have long distances and those supply chains are going to be threatened. So what are we doing to affect that? And what is our strategy and what are we thinking about it? So just overall, our strategy in the Air Force in this one particular area is to maximize combat capability. That's our job. That's what the taxpayers pay us to do. And by doing that, in wartime, that allows us to deliver more combat air power. In peacetime, that allows us to save money to put back into mission. There's also a secondary effect with greenhouse gas emissions that we have less of that. But our focus is how do we get more bang for the buck out of the platforms that we have right now? And what are we developing in the future? And how do those new platforms affect our ability to support the fuel logistics supply chain gap that we see in order to deliver more combat air power? You can see we have goals that are based off of that, and I'll cover each one here in succession. But the goals look at two primary areas. There's a process area, so how are we planning and executing missions? Are there ways that we can do that better? How do we analyze the data post-mission to see where we could be better? Because for us, more time on station, more fuel delivered at range, more cargo delivered at range is success. Then the other part is what technologies are out there, both in the sustainment of aircraft platforms as well as in increasing aerodynamics or decreasing drag in our platforms to let us go farther, are out there, and what are we going to do? So I'll go very kind of tactical and go through specific examples of what we're doing right now. We're spending roughly 100 to 150 million over the next few years each year to look at these things, to test out technologies, and to get them on our platforms. So for legacy fleet innovation, one of the main things you'll see here is that there are ways to take through computational fluid dynamics our legacy platforms. In some cases, 3D printed fins that are glued to the side of our aircraft can get us 1 to 3% drag reduction. You'll see that some of the platforms are very common to our partner nations, so C-130s and C-17s. We're actually going back through the C-130 and refining that process so that we could have a better solution that increases range. And the big thing for these, though, is that as we work on sustainment issues, we have to understand that the application has to be fairly simple to apply. It has to require no maintenance, and it has to have some kind of benefit to mission. Much in the same way we've looked at data, there is some value to, we found, like in the aft body drag reduction perspective, that when you collect the data, you realize that most of the aircraft will look just like the computational fluid dynamics is telling you with respect to performance, but some of them don't, and that's because we have old aircraft, some of them are bent and need to be re-rigged. Some basic things, just like windshield wipers. We team a lot with Delta Airlines to look at things that they are interested in because we think there's a benefit to us, and something as basic as a vertical windshield wiper will get us about 1%. When you start adding up on certain platforms like the KC-135, the aft body drag reduction, some engine improvements, some other drag reduction improvements, fixing antennas that are not aerodynamic, you can actually start getting close to double-digit performance and efficiency. And then there's something to be said about the way our process works with respect to wing commanders and what is a priority for them. They do not have a fuel budget. They are told this is how many flighting hours you're supposed to fly, and the crews behave in that way where fuel is free. And so we are spending some time looking at that and incentivizing our crews to think differently about this. On the front end, it's going to mean that, and we've seen a pretty good reduction at a couple of test squadrons that we've looked at, about 10,000 pounds of fuel reduction per flight, which ends up, being for 2 locations about $4 million in fuel use that was reduced just by thinking about fuel differently. So that part on the front end is providing cash incentives to those wings to think differently. But on the long end, it's actually to change the culture, to have everyone realize that unlike previous recent air wars that we've had, that fuel and that fuel saved means somebody else has more fuel to conduct missions that we couldn't have done otherwise. And then we are looking at engine optimization. I'm not going to steal the thunder of Jill from Pratt Whitney, but we are looking at engines, engine shapes, engine coatings, engine washes, as well as other things, sustainment activities that we've done in the past that could be better, that result in engines staying on wing longer, drag reduction in other areas where we would repair things, and those repairs would result in more drag on cowlings and whatnot. So we spent a fair amount of time in this too. So you can kind of see that we dig into a little bit of everything, the way the airplane's designed, the way we sustain the airplane. And then finally, we're looking a lot at the way we plan and execute missions, because what we've seen is that, one example, and that's really why my office exists, that young gent up in the upper left-hand corner is showing a solution that used to be, and right behind it, you can barely see the whiteboard. In Al Udeid, which is one of the main bases that we were operating out of in the Middle East, we were using a whiteboard with dry erase markers and magnets to schedule a 250 receiver, 50 tanker schedule every day for 15 years. And nobody thought that, hey, there's a better way to do this. Just by digitizing it, we got a 4% improvement, which is about 200,000 gallons of fuel saved per week. So that's 200,000 gallons that could be used elsewhere. That's crews that could be used elsewhere. That's 200,000 gallons that could be delivered in that theater. And by digitizing it and then putting an algorithm in it, we were getting an extra 10% on top of that. So that's close to 1 million gallons of fuel saved per week in one location, which is more air power for us in that location or somewhere else. So we're spending a lot of time thinking about that as well. And finally, we are spending some time looking at blended wing body technologies, because we think this is the 21st century Air Force for large aircraft. So we've got an initiative going right now. We're looking at a couple designs. We're going to down select from those designs to one. And we see benefits in both air refueling at range, where you can get much more productivity, much more fuel delivered. 7 F-35s as opposed to 1 at 4,000 miles would be a big capability increase for us, as well as cargo. The cargo airplanes that we have right now are very good airplanes, but they could be a lot better when you start taking away the tube and wing designs and start looking at more of a blended wing body design. So finally, for us, we burn close to $2 billion gallons of fuel per year, which equates to about a small airline in the U.S. That's all of our liquid fuel is more than all the other assets that the U.S. DoD has, all the tanks, all the ships, all the Navy helicopters, whatnot. Those are all less combined than what the Air Force does. So we can make a pretty good impact on how much we spend on fuel by pulling in these technologies. And we see us burning liquid fuel for a long time to come, just because of the energy density of the liquid fuel. And I finally say that, so for us, we are going to be flight following sustainable aviation fuel developments. You won't see us developing big amounts of sustainable aviation fuel within the Air Force, but we will be ensuring that what's available to us, include those mixtures and include sustainable aviation fuel, are compatible with our platform so we can proceed on. And then just a plug for Kevin, we're going to have an operational working group here coming up in October, November timeframe here in the States. So looking forward to hearing your questions. Thank you.
Thank you very much, Roberto. And now let's get the perspective of the Luftwaffe. We're joined by Brigadier General Holger Newman.
So, sir, ladies and gentlemen, thank you so much for the opportunity and be part of the initial panel of the sustainability piece of this conference. I'm responsible within the German Air Force for future development and plans and policies. And I'm a fighter pilot by trade, and you will recognize it in a minute. So planners like me are often being asked, okay, what will change? Okay, how will the future operating environment look like? How how is the way we fight going to change? And yes, there are multiple trends and ideas and plans out there, and they're all linked to artificial intelligence, manned, unmanned teaming, connected by a cloud, and so forth. But it's actually very hard to tell how we're going to develop our future capabilities unless you have access to the famous crystal ball on the left-hand side. What we do know already is that our global environment has changed and is continuing to change. And as mentioned before, there is no planet B. We all know that, so it's everyone's responsibility and task to take care of our planet. And these effects caused by climate change will have effects on the way we fight, on military operation. They may differ depending on which domain you're fighting in or which global region you're in, but they will affect our operations. What will not change, however, is the key task of air power, and that is to gain and maintain control of the air and to some extent space. This task was not the focus in the last couple of decades since we fought counterinsurgency operations, but it is when you're facing a peer opponent. The way we fight and our unique capabilities are based on speed, reach, precision, and agility. And that makes air a first responder of choice. What will also not change is what is needed to fight and to survive in the third dimension. That is, operating in the third dimension requires specialized personnel, in our case airmen, and specialized systems and equipment. We should not forget that we operate in a life-threatening environment, even without opponents. There's a reason we're wearing helmets and masks. Not only they look cool, but we needed to survive up in high altitude. Okay. Apart from this life support in high reliable systems, in our high-end missions, we need and we depend on jet propulsion. Okay, there's no alternative or substitute in the foreseeable future. So we need thrust available to conduct our mission. For example, deploying tons of cargo around the globe within a couple of hours, or to turn and burn in a 9G air combat. As I said, no alternative so far. So to keep it short, in thrust we trust. But does that mean we are not compatible with sustainability? No, it's not, because don't forget, it's one planet we have, and we have all to take care of our planet Earth. And of course, and that was mentioned before, not all our missions and installation and stuff is high-end, okay? That's not everything is 9G, but we can save energy in our installation and in the routine ops. And that was also mentioned just a minute ago, efficiency and sustainability equals combat power. If you burn less fuel than your opponent, you have a longer station time, you can use more afterburner, and you can win the fight. And of course, the overall setup, for example, if a deployed airbase and you are able to reduce the energy consumption and supply consumption, you can reduce your footprint, which is has a lot of advantages. Okay. So how does our game plan look like? Since climate change is a multinational challenge, also affecting international security, there are many plans out there. Germany just issued a national security strategy reflecting this nexus between energy, also reflecting this nexus also between climate change and security. Quote, curbing the climate crisis and dealing with its consequences is one of the fundamental and most pressing tasks of this century, end of quote. In addition, as you know, there are also multinational agreements and laws and the action plans. And in 2022, so last year, the Luftwaffe published a point paper on sustainability, underlining that we're locked on the goal of reducing carbon dioxide. And I'd like to give you two examples out of that. One, that doesn't come by surprise, is the use of sustainable aviation fuel. So although our motto is in thrust we trust, we know that we are responsible for a significant amount of greenhouse gas emissions with that. So we can mitigate this by using sustainable aviation fuel. But also mentioned, we cannot accept, at least not in our high-end missions, operational limitations. Okay, we cannot, lose thrust or have altitude restrictions concerning or based on the fuel limits. Our guiding principle, however, stays avoid, reduce, compensate. So the best fuel for our planet is the fuel not burned. It's a lead-in for my second example, being training. And the Air Forces, as you know, we are innovative, we are multinational, and we are responsible. So what we're trying to do is we try to move people, not information, okay? We have great ideas, and we executed these already in training and setting up training and courses. And this significantly reduces the carbon dioxide footprint. And since we're multinational from training and other operations and so forth, that's a great basis for joint ventures and cooperation. Okay, and we are responsible because we know that to some extent in our high-end missions, we need to burn fuel, and that makes us more responsible and important for us to save this gas somewhere else. Okay, and one of the P's is the combination of live training and simulation training, which is called live virtual constructive. And we see a lot of potential in this area. That's one of the reasons why our Air Chief decided to take over the lead of the GASCC23 working group training, because LVC will be will increase fighting power and training quite significantly. To wrap it up, and maybe to stimulate the upcoming discussions, we consider ourselves being on the leading edge towards the goal of sustainability. Our core mission task is operational, worldwide, and sustainable, SAF-ready. Thank you for your attention.
Thank you very much, Olga Newman. Now let's turn to the Italian Air Force now and get the insights of Brigadier General Stefano Cimicella.
Good morning. I'm Brigadier General Stefano Cimicella, Head of Department and New Programs of the Infrastructure Division of the Logistics Command of the Italian Air Force, leader of the Infrastructure and State Working Group of the Global Air Force Climate Change Collaboration. I'm very proud to be here today in the year of the centenary of the Italian Air Force to illustrate to you how we are trying to accelerate the path towards our goal to the net zero energy of the building assets at 2040, in line with what our centenary's motto says, flying towards the future. This is my agenda. I start with a short introduction to the environmental and energy policies of the Italian defense in the EU and Italian regulatory framework, the lines of action undertaken by Italian Air Force to reach the net zero energy of the building assets, some future perspective we are planning, and finally, some conclusion. The EU has been at the forefront of the international efforts to fight climate change by setting itself increasingly ambitious goals. In fact, in 2019, with the European Green Deal, the EU aims to be climate neutral by 2050. That it means an economy with net zero greenhouse gas emissions. In 2021, with the program Fit for 55, was adopted a package which sets the EU's policies in line with its commitment to reduce its net greenhouse gas emissions by at least 55% by 2030, compared to the 1990 levels, increasing the production of renewable energy at 40%. In 2022, the European Commission, in response to the difficulties and disruption on the world energy market caused by Russian invasion of Ukraine, implemented the REPowerEU plan, which is helping the EU to save energy, produce clean energy, increasing renewables at 45%, and diversify our energy supplies. At the national level, the strategy against climate change towards energy transition as defined with the National Energy Strategy in 2017 and with the Integrated National Plan for Energy and Climate in 2019, defining, among others, the middle-term objective to be achieved. In 2019, the implementation plan for the defense energy strategies was adopted. As to the infrastructures and building sector, the implementation plan focused on the following points: importance of the building assets and its energy performance, the need to increase energy production from renewable sources, including biofuels, the development of a new concept of military base under the energy-related perspective, the smart military district, characterized by improved levels of energy efficiency, autonomy, and resilience, enhancing the use of technologies towards decarbonization. Italian Air Force has a huge infrastructural asset: 26 airports, 50 main operating bases, 3 main headquarters, 5 training institutes, radar centers, ammunition depots, and so on, in which over 10,000 buildings with a floor area of over 5 million square meters are located. Most of these buildings were built between the 60s and 80s of the last century, with poor energy performance indexes, needing to be upgraded by extensive plan of renovation works. Energy consumption is still quite relevant, with the primary energy consumption over 600 gigawatt per hour in 2022. Accordingly, the estimated total carbon dioxide emission in 2022 for buildings operation, that is heating, air conditioning, lighting, electric power, is approximately 120,000 tons. Air Force spends roughly 55 million euro per year for its non-operational energy, which is about the 40% of its operational energy. To reduce these numbers, important initiatives have already been started. Among them, first, improving the energy performance of the existing building assets. For the new buildings and infrastructure, we will make them compliant with the latest rules on energy efficiency, which dictate to implement nearly zero energy buildings. And we will continue planning and implementing huge impact projects to improve our bases towards smart districts, compliant with the needs of a modern and professional armed force. An extensive energy audit campaign has been launched on the most relevant and high energy consuming bases to monitor their energy performance and better identify every useful intervention needed to improve it through an accurate cost-benefit analysis. Consequently, a wide energy efficiency upgrading program was launched, both with funds from the ordinary defense budget and with the extensive use of financial tools provided by Italian Ministry of Ecological Transition and by the Ministry of Economic Development, to improve the energy performance of the public administration buildings in accordance with the EU directives. In the last decade, we have already executed energy-related renovation works for an amount of about 39 million euro. Energy-related renovation work has been approved and financed by competent ministries for 78 million euros, and approximately 104 million energy-related renovation projects are under approval, which lead to a cumulative financial effort of 221.8 million euro. All these interventions would ensure a reduction in terms of carbon dioxide emission of about 22,000 tons per year, corresponding to about 18% of current emission, such as the CO2 absorbed by 1.2 million trees. The following slide presents a quick overview of the recent works of energy efficiency upgrading made on different types of buildings and infrastructure we have included. Works to upgrade buildings' energy performance, as for example, those completed in Pozzuoli, our Air Force Academy, and to improve efficiency through cogeneration systems installed in Cameri Air Base, earthing lighting conversion to LED with a 40% estimated annual cost savings. The realization in 3-year period from 2013-2015 at Amendola Air Base of all the operational infrastructure to support the new aircraft F-35, such as maintenance hangars, shelters, operation building, with an investment cost of about 200 million euro. All the infrastructure are certified by LEED at gold level, characterized by 25% lower overall energy consumption compared to a standard building with similar characteristics. In the next years, the Italian Air Force will be involved in a great long-term impact infrastructural program called Aeroporti Azzurri, Sky Blue Airport. Rapporti Azzurri essentially consist in renovation and construction of operational infrastructure, logistically and technologically compliant with the latest generation weapon systems. Renovation of all the networks, infrastructure, such as electric grids, drinking water pipelines, sewerage, to guarantee a functional and energy sustainable infrastructural state and lower environmental impact. Realization of logistics infrastructure compliant with the needs of a well-being and a modern professional armed force. The program, already outlined in its main lines of action, has a financial magnitude of 1.7 billion euro and a temporal development of about 12 years. Obviously, will be based on criteria of maximum energy efficiency and reduced environmental impact in line with the best technologies available. In particular, the new buildings and those undergoing major restructuring will have NZEB characteristics, while the efficiency improvements of the remaining infrastructure will continue. For the future, Italian defense has given itself the objective to convert its main bases into smart military districts, as outlined in the implementation plan for the defense energy strategy approved by our military leadership in 2019. As for the Italian Air Force, all the strategic and military airports and command centers will be converted into smart military districts, characterized by high energy efficiency building assets, thanks to insulation of the envelope of the building and the use of the most advanced plant technologies. Extensive use of renewables and energy storage, even by using hydrogen as energy vector to reconvert in electric energy when needed, to be able to postpone the use of the production surplus of energy produced by solar photovoltaic modules. Implementation of a smart grid where control and monitor energy flows inside the district through secure energy and data networks. Remote management of all active energy systems in the district with an integrated energy management system designed to minimize vulnerability to cyber attacks. And now some conclusion. Climate change is without any doubt a global challenge and a severe restraint to security and prosperity of our societies. Italian Air Force is fully committed in reaching the net zero energy of the infrastructural assets by 2040, and to do this is launching a broad spectrum of projects and works. Improving energy efficiency and implementing some of these huge impact projects, such as the Sky Blue airports, or planning the future smart and military districts, we will ensure a sensitive reduction of energy consumption and harmful emission in atmosphere and the achievement of the energy autonomy of our infrastructural assets. Through this integrated system of initiative, Italian Air Force will be able to execute its mission for the next decades in a fully eco-sustainable infrastructure context, more efficient, more reliant on renewables, and therefore more resilient. Now, as a leader nation of the Infrastructure and State Working Group, and in line with the tasks assigned to the working group, I'm glad to announce that we are planning to organize our third meeting in Italy during the last quarter of this year. Sure of the importance on sharing ideas and information among the nation, part of the networking group, your kind participation is more than appreciated. Thank you.
Thank you very much, Brigadier. So now I would like to hand over to Jill Albertelli, President of Military Engines at Pratt & Whitney.
Thank you, and it's great to be here with everyone today. And as stated, I'm Jill Albertelli, the President of Pratt & Whitney for Military Engines. It's truly an honor to be here with all my colleagues as well. Last year I attended this conference, and like many of you, listened to the Sustainability and Skills session, and also witnessed the signing of the Global Air Chiefs Climate Change Collaboration Declaration of Intention. And for me personally, it was rewarding because it renewed my own dedication to find ways that my business at Pratt & Whitney can leverage resources and research capacity to ensure that we are all together tackling climate change. And as we know, impacting climate change has been increasingly hard to do over the last few years as we collectively find ourselves in a perma-crisis. Our physical world is rapidly changing. There's no escaping the urgent need for CO2 emissions reduction. Our effort on this front is happening against the backdrop of unprecedented geopolitical instability, a global pandemic, rising fuel costs, increasing regulations, and skyrocketing inflation. The pressures are truly enormous. Regardless of this reality, we cannot slow our efforts to problem solve on the sustainability front. As leaders in aerospace and defense, we all understand the impact global supply chain efficiency has on operational success. And as often stated by our defense leaders, experts talk logistics. In context of sustainability, our logistics and supply chains provide opportunity to lower our carbon footprint. As already stated today, our militaries cannot wait on critical items to execute their missions. Readiness has to be at the heart, and has always been at the heart, of NATO's top initiatives. So as a former leader of supply chain at Pratt & Whitney, I can tell you that we do all possible to consolidate shipping with our sister businesses and maximize ground transportation to avoid air transport due to its high carbon intensity. We actively utilize reusable kits to move products in and out of our sites to minimize packaging impact. We are also exploring bio-based alternatives for minimizing single-use plastics. And our employees truly continue to find ways to work differently, which result in sustainability benefits. As a business, there are 3 key questions we need to ask ourselves in the spirit of making sustainability decisions while doing no harm in the process. The first question is, will it support warfighter readiness by streamlining logistics, and will it reduce instability in the system? As we know, a stable system is obviously the better. The second is, will a decision introduce technology that creates digital connectivity and supports real-time data, and is that actionable? If the answer isn't yes there, it's reason to pause and reevaluate. And then a third question is, will this decision introduce advanced manufacturing technologies like additive that will control variation and create consistency? Nobody wants surprises, not us, not all of you, our customers, and certainly not our military leaders on the battlefield. You can positively answer these questions, and if you do, you're likely adopting a technology, creating a policy, or introducing a new process that will help support a sustainable ecosystem worth having. So let me give you some examples from Pratt & Whitney. The first was when we said yes to all 3 of these questions, we began discussions around the need for a new turbine airfoil production facility. We needed this to support our high volume programs like the F-135 for your F-35 aircraft, as well as its engine core upgrade. Last November, we opened the doors to a 1.2 million square foot LEED Silver certified facility in North Carolina. It was built from the ground up, truly to feature several sustainability and environmental initiatives. And we significantly streamlined the processes and reduced the unnecessary travel of key parts by 2,500 miles. That change alone will pay huge dividends over the decades to come. And all of this was done with the understanding that what matters most is our ability to quickly meet our customers' needs, whether that be on NATO's eastern flank or in the Indo-Pacific. So, all of us play a very important role in holding ourselves accountable to setting and reaching sustainability goals. And it's not a given. An organization doesn't always make decisions based on sustainability drivers, and that challenge is definitely exacerbated when the exact right sustainability decision isn't clear. We continue to develop technologies that offer greater efficiency, greater range, and payload capabilities. As you likely know, Pratt & Whitney was a trailblazer of a high-efficiency airliner option with our geared turbofan engine. In our commercial world, that saved over 1 billion gallons of fuel since 2016. Our solutions in development will burn even less fuel, and that's better for our climate, our operational readiness, and our energy security. Jet fuel comprises approximately 80% of the US Air Force's energy budget. About 60% of that fuel is used by transport aircraft, which are primarily serviced by commercial derivative engines, such as the Pratt & Whitney F-117, which powers the global C-17 fleet. We recently signed an engine sustainment support contract on the F-117 engine with the US Air Force. It supports availability, affordability, and sustainability objectives. This is for the US Air Force as well as our international C-17 fleet. It will increase the F-117's fuel efficiency by 1.3% and extend time on wing to save approximately $20 million US per year through reduced fuel and costs for shop visits. More critically, that fuel efficiency will reduce the C-17's carbon footprint. And what about fuels which power the aircraft in general? Fuel burn is ultimately the main contributor to CO2 emissions and our environmental footprint as a whole. That's why, as many have said already, sustainable aviation fuel is critical. It's critical on our commercial aviation industry's drive to net zero, and it will be for military engines too. I'm pretty happy and proud to say that all of our engines today are ready to run on SAF with a 50% fuel mix with Jet A. And we also have extensively tested our engines on 100% SAF, including our F-135 fighter engine, again, successfully. SAF constitutes well below 0.1% of the jet fuel burn today, but this percentage is certainly expected to rise, and our military engines will be ready to operate seamlessly with these alternative fuels. Through our involvement in several organizations like the Commercial Aviation Alternative Fuel Initiative and American Society for Testing and Materials, we've been actively involved in defining the specifications that allow SAF to be used and continue to work towards enabling future fuel blends of up to 100%. I think we can agree that reducing fossil-based fuel sources is the right call, so I don't think there'll be a debate there. But what about hybrid electric? We are advancing hybrid electric propulsion technologies as well across a range of demonstrator programs with collaborators truly around the world. In Canada, we are developing a hybrid electric flight demonstrator targeting 30% efficiency improvement for regional turboprop aircraft supported by the Government of Canada and Quebec. We are developing a hybrid electric gear turbofan engine applicable to single-aisle aircraft as part of the SWITCH project supported by the EU's Clean Aviation Program. And with our STEP Tech demonstrator, we're developing technologies for distributed propulsion architectures, which could support the future high-speed eVTOL craft, including for battlefield mobility applications. These projects leverage electric motors that will be in the range of 0.5 to 1 megawatt class capability. So that unleashes a raft of efficiency and power capabilities for future aircraft to enhance efficiency, enable greater range, lower noise operation, and provide greater electrical power for mission systems, including directed energy weapons. So like many of you, I will be leaving the conference in a day or so and headed over to Riyadh. We will get to see and watch the power of the F-35 and its F-135 engine on display. And again, I'm proud of the work that's been done by my team to support this incredible capability for both us and in the US and our allies. But as you've heard, Pratt & Whitney is deeply committed to sustainability and sustaining net zero operations. It won't be easy, as we've all stated, as there are difficult challenges ahead. All of us, though, must broaden the conversation around sustainability to include all facets of what we do. As we look to the future, our efforts must focus on the entire aerospace enterprise to balance sustainability, capability, and availability. If we do that, we will make rapid progress towards reducing climate change and will be able to move closer to net zero while ensuring our militaries have the best capabilities they need to meet the security objectives outlined by their governments. Thank you for your continued dedication to leading sustainability progress across the globe.
Jill. And our last expert speaker for this opening session is Jay Williams, Head of Engineering Integration at Airbus.
Good morning all. So yes, I'm Jay Williams. I'm working in fuel systems in Airbus in the commercial sector. So going last is sometimes a tough gig in these setups, but I won't repeat the good words that we've already had from our military colleagues. And instead, if I can offer any unique insight, it'll be around what the aircraft manufacturer's perspective is and how we look at the synergies between commercial aviation and its challenges to decarbonise versus our military aircraft. I'll do that in two sections today. First, looking at the impact of climate change on our aircraft and on our operations, and then clearly what are Airbus doing with others to lead on sustainability. So I'm pleased and proud to start with this first picture. Paul talked about the successful flight test of SAF on the Voyager, and for me that shows the progress. When I was here last year talking about SAF to you, that we also show a huge amount of progress both on commercial and on the military side. And I'm very proud that our team in the UK in fuel systems will help working with our colleagues and friends in the RF to enable that 100% SAF flight test. And I'm also pleased and happy, a special welcome to our international colleagues. You know how we Brits love to talk about the weather, and so I thank you for this opportunity to do that today as I describe some of the challenges that are coming up for our aircraft. So reinforced by the latest IPCC report, it's clear and reinforced that our greenhouse gas emissions as part of climate change are leading to extreme weather events and larger in their frequency and severity. Airbus Commercial having 13,000 aircraft in our global fleet and 10 million flights per year, we have to anticipate and to study these risks to the global fleet, but we'll also use that learning to understand the military aircraft applications and how that would give us an edge if we anticipate. Just quickly looking at these in turn then, so clean air turbulence is studied closely and known to be increasing in its frequency and severity. Storms and their frequency and severity is also increasing, which from a commercial aircraft operations has a compounding effect because the air traffic management provisions to redirect those flights is also increasing the emissions that we're trying to curtail. Specific damage from icing and hail and lightning, in these very severe events, they can require repair. And so again, that's impacting the aircraft downtime and availability. Ground and air temperatures. Air temperature is a key parameter in the takeoff and climb performance, both of the airframe and of the engine. So understanding weight limitations and how we operate the aircraft in those more aggressive environments is important. And on the ground, it can impact things like corrosion, wear, tyre life, and also the ability of our maintenance crews to work with the aircraft in comfortable and unimpeded situations. Flooding is also a real risk. If you look at the commercial studies done to date, the anticipation on the current trajectories is that 20% of coastal low-lying airports will be in a higher risk category by the end of the century in terms of local flooding. So in Europe, that means roughly 2/3 of the coastal airports would be in that risk category. If you think of the impact to that in terms of the commercial aviation network, that's going to be huge to anticipate. But also for our military operations, having that anticipation and agility in the fleet is going to be really important to adapt to those issues. So in terms of the military aircraft, clearly we design high-performance, robust, versatile and agile aircraft. So I think that any risks to the individual mission are low, but it is something that we need to anticipate in terms of how we use our fleet, how we maintain our fleet, and how we plan our operations in the future, because forces that do anticipate those effects will end up having that competitive advantage. So what are we doing to reduce the uncertainty and address these risks? Well, really, we need scientific cooperation here. In many of those instances, it's the aviation industry alone that are concerned by some of those weather effects, certainly in terms of cruise altitude and icing and weather patterns. But we do have a really good history of using aviation and meteorological collaborations. For example, the Argos campaign is a scientific endeavour where we use airborne measurements on commercial aircraft to validate weather models and weather predictions, and we need to do more of that to understand these phenomena. In terms of mitigation, Much like any new design driver or uncertainty in the design space, the increasing use of models and of digitalization techniques is going to be the key aim, not only to anticipate sustainability and climate challenges, but also to get the competitive advantage. We are continuing to invest in the end-to-end environmental modelling, so not only of the aircraft, but its complete end-to-end setting in terms of weather patterns, ground ops, things like humidity in different airports to look at corrosion rates, so we can not only enhance the aircraft, but also how it's maintained and serviced. And we don't have any services on these specific risks as yet, but knowing that we have a really great platform with fleet data and a backbone for those services and collaborations with many air forces, such as the Smart Force platform within Airbus, means that I'm confident that with this digital strategy, we can help work very closely with our Air Force partners to get the best out of the aircraft in whatever those operational scenarios and risks might be. So what are we doing to mitigate these events? So Airbus's vision, I think I explained last year, is to pioneer sustainable aerospace. And I spoke to you last time around our journey on SAF. Since then, I'm pleased that we're making progress on many, many fronts on SAF. We talked about the A330 100% SAF flight. We've also trialled the C295 and 400M with different SAF blends, and we were happy to see the RAF successful air-to-air refueling with SAF blends. In terms of my team and the impact that we have within Airbus across the divisions, we are continuing with compatibility flight tests. We're leading on some of the specification development for fuels, as noted with Pratt on ASTM. We're supporting national strategies, both in civil and military and helicopters. We're advocating for production ramp-up. That is the phase now that we need to action. And we're taking some direct investment and strategic partnership announcements to try and get that SAF production up. And some of that, from an engineering perspective, starts with the responsibility to work with fuel producers to look at their constraints, look at their bottlenecks, look at their cost drivers. And we have strategic research partnerships on both infrastructure and feedstock opportunities to look at new fuels. In terms of continuing those commercial and military synergies, we will always work on platform efficiency, on technology efficiency for the aircraft. But it was also mentioned about operational efficiencies. I think this commercial pressure to optimize in the commercial realm will have synergies and opportunities that we'd look forward to working with our military colleagues on. And although, as mentioned by Paul, not potentially impacting hugely pre-2050, but Airbus are industry leading when we look at our liquid hydrogen concept aircraft in Zero-E to look at decarbonising beyond 2050. So in addition to the main priority, which is to decarbonise, there are also other sustainability impacts that we need to understand. So clearly on non-CO2, when we're talking about NOx, particulates, contrails, there is a lot still to do to understand uncertainties, scientific uncertainties about the relative merits of taking action versus the risk of creating more carbon emissions. And so again, similar to the weather topics, we need scientific partnerships. We're investing with academia to try and understand that. And having the aircraft as a measurement asset is still really powerful in that. I showed you this plot last year where we're doing direct emissions measurements from civil aircraft to understand the direct link between fuel types, particulate emissions and contrails, and we need to continue to do that. But also I think that for this community, there are opportunities between commercial, military, and definitely space to look at the measurement, understanding, and monitoring of contrail formation, and that's something that we're looking at to mitigate non-CO2 emissions as well. And then to all of you in this room, from the perspective of having a commercial outlook in terms of civil aviation, I think you guys have a real, tangible, specific, and really exciting opportunity to address the sustainability challenge of the industry, not only in military aircraft. It's been talked about before, but I think your strive for energy security, energy independence may drive us to new fuel types, to new fuel pathways, to new infrastructure options, which are going to only help the sector. I think you have the ability and the assets to lead on prototyping, on flight testing, and the flexibility to use the aircraft to do demonstrations is something that's really impressive to us, and we've seen that with the RAF. And often you're close to those who will listen. In terms of government policy, I know I welcome the RAF's involvement in the Jet Zero Council in the UK, but having that pressure and that strategic view with government is really going to help the whole sector. So I thank you for that, and I look forward to Airbus supporting you on your sustainable missions. Thanks very much.
Thank you very much to Jay Williams as well. So we're going to move on to our Q&A section now. So I do want you to pose some questions to our panellists. So we do have some roving mics that are in the room, so do please put up your hand. I've got a number of questions that have come through on Slido. First of oil, I should say, we're talking about energy, very apt. So curious as to the degree to which emissions are informing new AC purchase decisions and not just existing fleet upgrades. So when we're coming to aircraft purchase decisions, how is our emissions really forming these decisions? Who can take this one?
You want to start and then I'll carry on.
Thanks, Paul. So across all government procurements, the cost of carbon and carbon emissions should already be part of all procurements through the Green Book Supplementary. So that's our Treasury's guidance in terms of how we take in different accounting standards as part of the actual process. It's fair to say that there hasn't been the focus on it that there should have been, but with all the changes that are happening across government, across the UK, all linked to the UK net zero strategy, I think there will be a greater focus going forward on ensuring that at the very start of the process, any new procurement in its strategic case will be looking at this either through the economic or the strategic case.
Okay, thank you very much. Another question has come through. The UK MOD, this is from Phil Clare, appears to be addressing the existential threat of climate change with individuals occupying double and triple hatted posts. Is that appropriate, he asks? Is that the approach of other nations? Well, let's ask if it is appropriate to start off with. Do you think it's a real hindrance to progressing what needs to happen here?
So I think it's probably a question on my job title, which has been made several times before, including the Daily Telegraph. So if you take a step back in terms of levelling up in the Union, at the heart of that is about economic sustainability. So I think it is quite powerful that economic sustainability and environmental sustainability are talked about in the same way. There are many interfaces between that. We talked about sustainable aviation fuel. We talked about the price point, but there is something quite powerful if defence uses sustainable aviation fuel, thinking about then the economic growth prospects of it all, thinking about where our bases are, the other opportunities. So there is actually something powerful about aligning it. Will I acknowledge that they are two quite broad agendas? Yes, but at the moment we have to navigate our way through them.
Okay, well, let's get the perspective then from Luftwaffe. Would you say that that's the same for your force as well, that there are too many hats worn when it comes to such crucial decisions?
Well, it depends. I would say, first of all, with this GASCC23 initiative, we have a tool now where we explore these topics. But I think also there's a chance in the combination of if you're double-headed or triple-headed, because you have to think it at its one particular topic. If you go operation on one side, high performance only, and have another department or division taking care of the sustainability piece, you have a kind of a disconnect within your own system. So I think the strength lies within the combination of both. And yes, we have to put more emphasis on it.
Everybody should wear a sustainable hat, essentially. Okay, thank you. Now, there's a question come from a taxpayer. How are Air Forces collaborating with their national net zero initiatives to minimise costs to the taxpayer? Would taxpayer money spent on air-based solar panels be better spent decarbonising the national grid? I think this is very UK-focused. We can broaden it out in a moment. Paul, do you have...
I'll start. I mean, I look after infrastructure as well in the Air Force. So, I mean, that's a good question. And I think the point we'd say is all of these have a balance of investment decision. So those activities are looked at. I mean, there's an element of us trying to understand how we can make our bases more resilient. And you'll hear over the course of this about agile combat employment and the need to, in the world we live in now, particularly, our ability to become more resilient. So if we make our bases resilient with solar panels or possibly wind turbines, slightly less so, then that's something we would wish to do. So we would wish to help the national grid do its element, but we need to be ensuring that we are resilient as well. So I think that has a value to defence that we need to take into account.
Okay, thank you very much.
One of the things that has come out in the climate change collaboration and actually from the discussion with the Royal Navy is the real instance of how our air forces, unlike the Navy or the Army, we fight from our bases. And so how we look at energy on our bases is really part of how we deliver our effect. Again, the Army trains and lives at their bases, and they go off to somewhere to fight, and we usually take them. And at the same time, so does the Navy. They go off to fight. We fight from our bases. So how we integrate energy efficiency and turn the prism on how we fight is really important at our bases.
Okay, thank you very much. Now, there's another question come through. How can air forces leverage localized modular nuclear energy, especially noting the capability for generating synthetic fuel? Really interesting. I was at the EU Nuclear Forum last November, where clearly many of these solutions were being pushed. Roberto Guerrero, how would you assess the potential for modular nuclear energy here?
So we've looked at that. We see that the energy in versus energy out is quite a challenge. So for smaller production of SAF in remote locations, and the Pacific has quite big distances between island chains. For smaller types of aircraft, that might be a solution. We're actually, I think, doing a small modular reactor out in Eielson, which is a pretty remote place in Alaska. But just in general for us, the amount of fuel that can be produced through that type of process, it would make it challenging to conduct the type of flight operations that we do in the Air Force with big aircraft like C-17s or even the smaller, very hungry, F-35s. So.
Okay, thank you. Is there an industry perspective that we can bring in here?
I think from the aircraft manufacturer perspective, we are completely aligned to enabling more fuel type on the aircraft in terms of the fuel specification and the aircraft compatibility. There is a case still in the commercial world studying power to liquid and the costs and the energy footprint of those fuel types, but much like bio-derived fuels, there's still a long way to go in production ramp-up. So I think we want to be broad in our welcoming of all of those fuel production techniques, and for some, depending on geography and other energy sources, SMRs will be a real exciting opportunity.
Okay, thank you. Picking up on what we discussed a little earlier, I was struck by, Paul, what you were saying about how the use of SAF could actually, meet 35%, the target that we need. Yet, even though the technology is here, it's still not being produced in the quantities needed. What would you say the main bottlenecks are?
Well, I think colleague Jay would know as much about this. I think it's the infrastructure is just not there yet. So we don't have. It's not yet. We haven't made the economic case for why it is an efficient. We should be moving to that fuel type, and it's still therefore it's expensive. And you've got that sort of. I think it was discussed last year. We've got that sort of problem, which is without the demand, there's no supply. Without the supply, it's expensive. There's no demand. So we've got to kickstart that demand, which will then get the finance community to start thinking about investing in it, and therefore we can bring the cost down. So I think it's access to finance is probably the greatest problem. The technology is kind of A-level chemistry, right? So we kind of know what we need to do. It's getting into that.
Would you say you certainly need to have governments weighing in to support this before then the access to finance will come? Jill?
I think that, as stated, we're ready from a chemistry standpoint. As I mentioned, we can run already today on 50% fuel across the board, every engine, commercial, military, for Pratt, and we already are running at 100% SAF. It's the infrastructure, it's the cost. So we do need that support financially across the board, really to get it, maybe a jump start to get it going.
Okay, thank you. Brigadier, could I bring a point in that actually you mentioned prior to this session, just the very fact that if our drive to find more sustainable ways of operating, we're going to be highly reliant on the metals and minerals which are in short supply. Do you think this could lead to the potential for further conflict further down the road? And to what extent should this all be factored into the planning?
Yes. This is a problem of energy transition to replace a dependence from fossil fuels to raw materials, critical minerals, and that's the problem of energy transition. And I think that all NATO allies and EU member states has to face this problem in the future years. The solution, I think, one of the solutions could be invest in research and development altogether to face new supply chains of these critical raw materials, because this is the problem of the future. EU is doing its part, I think, with the recent adoption of the Critical Raw Material Act, sets some benchmarks for extracting materials, for refining these materials, for importing these materials. And this could be a solution for the future, no? To set some rules. The other way that the EU is trying to do is to enhance collaboration, even with the non-EU partners, to set supply chains in their own nation, their own nation. And the other way, important is to say that fossil fuels are dispersed all over the world. Critical raw materials are more concentrated. It's more dangerous. These are treated more dangerous than the past. So I think that in the future, we are very focused on this problem because this is the problem of the future.
Absolutely. Okay, well, thank you. There's a question here just at the front. If we could get the roving mic here. And in the meantime, I'm just going to ask Roberto a quick question from Ben Lolly. What is the plan for fleet-wide rollout of the drag reduction upgrades that you mentioned? And is it anticipated that you will share these upgrades with partner nations who operate similar fleets?
Sure, yeah. That's part of the reason we're, so the plans for upgrades to the C-17, we're going to do some additional flight testing because we've done some flight testing in the past to just to ensure the performance of those aircraft with these modifications to them. So that'll happen for at least the aft body drag reduction will happen in September, October timeframe. And then by next year, we're going to be doing some pylon fairing modifications. That's about another 0.5%, and that'll be complete by the end of next year. Similarly, in the C-17 and the KC-135, we're doing aft body drag reduction initiatives that should be done with flight testing by the end of next fiscal year, so around September of 24. And then absolutely, the partners that we're working with are folks who build these airplanes and want to share this technology with others who are buying these airplanes internationally.
Okay. So. Thank you very much, Roberto. Question here. Yes. If you could introduce yourself, that would be great.
Martin Hawley from Airspace Unlimited. The panel's spoken about imagination and collaboration, and Air Force fuel consumption is dwarfed by the civil flights. So Air Forces can actually multiply their impact by smarter use of airspace. And I wonder what the panel thinks of airspace, how it is designed, how it is managed, that and operated to show that this can be achieved. We can get some low-hanging fruit and very quickly from better use of airspace management. And just in reference to the Honourable Group Captain Kevin Billings, I'm not hallucinating because we're working on this technology ourselves.
Okay, Holger Newman, could I take you take that because it certainly ties into your presentation.
Yes, on the airspace, on the airspace issue, I think one of the great achievements of the last couple of years is the increase of simulation going on in our business. So we put some of the real-life training when we went through pilot training a couple of decades ago. I mean, the focus was on real flying, and you need airspace for that, of course. But now it kind of shifted to, I would say, 60% simulator, and then you go to the real aircraft. We also came up together with other allies with a so-called MRT, mission readiness training. So what you can do is you fly your mission. Let's say we go to Red Flag to Nellis, US. You can fly your missions like 5 or 6, 7, 10 times in the simulator back home. Don't burn fuel, don't need airspace, but you still need to work it. And you still have to have actual flying exercises, like we did just the Air Defender exercise a couple of days ago. You still need to do that, but you start on a higher level compared to former times because you can use this simulation. And what I stated in my briefing, the LVC, so the combination of simulating and the real training will be a huge increase in the way we train for our missions.
Okay, thank you very much. So we have, I think, another taxpayer who wants an answer to his question, or her question. On power-to-liquid SAF, what are the Air Forces doing to harness excess wind, solar energy within each nation's infrastructure to produce free fuel, rather than taxpayers paying to switch these power sources off when it's too windy, sunny? How does this tie in with your work at the MOD?
So there's a degree of what Paul was talking about before, and it's actually quite interesting where it's almost a counter to the previous question. So I know the British Army are doing solar PV at scale. They've had one of their first sites at Leconfield opened earlier on this year. So there is quite a lot of work actually ongoing. But interestingly, when I mentioned 1% of the UK, we still need our training estate for its primary purpose, which is training. So we can't just have large-scale PV across all our estate. The Salisbury Plain training area is pretty much all a SSI, which is a site of scientific special interest. So that's large calcified grassland. Can't do anything on there. So we're looking at not only solar PV, but wider land use. So somebody mentioned sequestration before, trees. I think the UK MOD has something like 35,000 hectares of peat bogs. So we're looking at maximising everything to actually sequester. We're also looking at maximising anything that we have as in terms of secondary benefits, in terms of the energy security and solar PV aspects of it all. But it's a complex set of interfaces, and we just need to pull it together.
I mean, that's the strategy you're taking in Italy as well, isn't it?
Yes, yeah, we are planning to starting with a huge plan of PV scale on all the base, our base, and about 29 air base in the next future. And we are planning to combine photovoltaic modules with hydrogen and lithium battery, because as you know, energy renewable are not always available when you need. So you have to have a storage capacity to postpone the use of energy from the production. So we are thinking to combine hydrogen, lithium battery, and photovoltaic. We are planning on the first project will be on a modular base. It's the base of the first base of F-35 with Air Force, and we think for about 67% of energy will be directly used in the grid for the use of the air base. The 14% will be used for storage lithium battery. To use these during winter time when solar energy is less. And the 16% will be used to produce hydrogen by electrolysis of water, and then it will be converted by fuel cells in energy during night. So with this triple system, we expect to reach the 97% of resiliency of the base. And so we have a double redundancy between hydrogen and lithium battery, so the maximum resilience for the base. And we are very committed in this project in the next years.
So that's the answer to the taxpayer. So there we are. Thank you very much. We don't have time for many more questions, I'm afraid. There's any more, one from the floor just here, and I've got one more that I'd like to ask.
So I'm Vice-Marshal AP Singh, Vice Chief of the Indian Air Force. I have one comment before the question. I think we could have the lights on when you have the question answer session so that you can see the hands being raised.
I know, yes, I couldn't see your hand. Apologies.
Okay. Anyway, I moved up for that reason. I have this is not for the panel, this is for the entire gathering here. We talked about low-hanging fruit. Saving emissions when we talk about, we could have had a conference like this in an open air. First, some radical ideas I'm trying to give you. We could have had all vehicles shared and electric. And more than that, let's think about it. Do we need to have an air show every year? Because when we're talking about our exercises, we can't do away with those. But can we do away with these air shows? So these are the ideas that I wanted to share. Thank you.
Well, who would like to take that? Who would be willing to forgo the air show?
Or look for an open air in the UK. There you go. What could possibly go wrong with that plan? So.
I mean, it does come up as well as another differing point that has been put across, just to start to wrap up this session. Given that the UK produces less than 1% of global carbon emissions, even if we achieve all the targets set out today, these efforts won't affect climate change. So is this not a huge distraction from the real threats that are out there? Any perspective on that?
For the global chiefs, we have 50 nations. They are percentages add up to become significant. So I think across all the nations we're talking through here, we start adding up to a reasonable percentage. Some of them are not represented, so I do understand that. But we are working together to work that, so each of us needs to do your bit. So as we said before, you can't afford to sit back and do nothing, both from an operational perspective, but also from our commitment side of the business. So I don't think we can do nothing, because if we don't, we will be caught out, as we've been in other areas. So I think we've got to do this, and together we're sort of I think we're a reasonable percentage if you added it all up. I think across the nations that have signed the GAC.
Okay, and just finally, Paul, there's another question for you that Air Commodore Andy Spinks wanted to ask. You said earlier the cost of SAF is 5 times that of fossil jet fuel. The procurement agencies bulk at that cost, so it could be 100 times the procured cost. Doesn't producing power to liquid SAF in theatre make overall sense on a cost basis?
It will do. The problem is, as we said, the technology exists broadly. The technology exists, not at scale, and so at the moment that is why it's so expensive. So in a sense, it's not sustainable. SAF is not sustainable at its current price point, and certainly on availability, because we're all going to be trying to get hold of it, and it just isn't being produced. So until we kickstart the business and it generates it at scale, it's just not going to get down in price, and therefore it's not going to be. The Treasury is not going to be very happy if we have to spend that money on it.
Okay, thank you. And I'm going to wrap up this session, getting the view from industry to this question that's come through from Tristan Corford from Ariel's IS. Clearly, the civil market is likely to lead on demand for transitioning to SAF, which will then make SAF more affordable for defence. What will trigger the tipping point for this to happen, and when do you think it will be? Do you have any sense of that, Jay?
So it ties to...
Jill and Jay.
You go first, go ahead.
It ties to some of the other questions around the incentives and how to get these price points down. I think both stick and carrot is a means by government. So we're talking about mandates in terms of showing the direction for investors that we will get there. And then after that, there are discussions around price point mechanisms and trying to support industries. I think in terms of tipping point, we're more going to talk about a gradual ramp-up strategy for the next 20 years or so. And I think, coming to the point about power to liquid, there are some elements that are just industrially scalable to bring the price point down. So, example, readily available electrolyzers, liquefaction plants, etc., for the hydrogen industry. But there are also some technology blocks that could not influence the feasibility of producing that fuel, but definitely the cost. So we're talking about catalyst evolution, the way to generate hydrogen, and to actually refine these fuels in a more cost-efficient way. So I think government are taking a real strategic approach, both on the commercial aspect, but also investment in the technology to bring that price down. And I think that will see the tipping point. But at the moment, I think it's a more of a steady growth. And once we see the market take that lead, it's the market reaction that will define the tipping point on price, I think.
Okay, thank you. Jill?
Completely aligned, excuse me, completely aligned, and I'd also say partnerships with many of the fuel providers today in converting refineries over is part of that timeline that we've talked about. But in the meantime, industry, we are investing so that we are ready for when it is available. But I agree, it will be a ramp up to get there.
Okay. Well, thank you very much for all of your views. We could keep talking about this for another hour or hours or days, in fact, but we can't. It's lunchtime, lunch calls. So please do give a big round of applause to the panel. It's been very insightful.